as a no, your non-standard electrode potentials were that if it's not under standard conditions. If it's not under standard conditions, the equilibrium is going to shift either left or right. If it shifts to the left, that means it's going to produce more electrons. So the potential would drop. It will become more negative. And if it shifts to the right, that means the substance will gain more electrons. The electrode will become more positive. So keep this thing in mind that if the equilibrium is going to shift either to the right or to the left, uh, so if it shifts to the right or to the left, uh, the electrode value or the potential value, it will change. It will become more positive or it will become more negative. Now, the thing is that, and I told you that you can measure this non-standard electrode potential by using the Nernst equation, which is E is equal to E naught plus 0.059 divided by Z. Z is the number of electrons. Log of oxidized species concentration divided by the reduced species concentration. And you can figure out the non-standard electrode potential value. So, so this is how you calculate non-standard electrode potential values. And the rest of the questions we'll do when we do past papers. So I'm just going to try and finish the rest of it, which is there are a couple of things which are left. So there's one thing that's left, and that's electrolysis. So we're going to try and quickly do electrolysis. Now remember, electrolysis is the opposite of what a cell is. It's exactly the opposite of what a cell is. A cell produces electrical, opposite of cell. So what a cell does is it produces electrical energy. So there's a chemical reaction, and because of that chemical reaction, electrical energy gets produced. So it converts chemical energy into electrical energy. So all we did so far was cells. We studied cells. So if I pick any of the cells that we drew earlier, this was exactly what was happening. That one of the electrode had a higher potential, like 0.81 over here, and one of the electrode over here had a lower potential, 0.68. So the electrons they started flowing from the lower potential towards the higher potential. The higher potential started to gain electrons, and the lower potential started to lose electrons. So because of the potentials that are set up by the reactions over here, a current starts flowing because of that. And so there's a current in the wire, there's electrical energy that is produced when this happens. Now going back to electrolysis. The electrolysis does the opposite. The current is already flowing. And that because of that current, so in electrolysis, what happens is that there is already electrical energy. So there's an external battery that's used. So the current is already flowing. And what you do is you convert that current into a chemical reaction. So because of that electrical energy, a chemical reaction takes place. So here's our first electrolysis. We're going to try and do the electrolysis of NaCl aqueous. So I'll have a beaker, and that beaker will have two electrodes in it. One of them will be the cathode, the other one will be your anode. So that's let's say that's my cathode, because that let's say that's my anode. And ठीक है. अच्छा, that's one. There's the other one. Yeah, they're going to meet in the middle. Not meet. There's going to be a battery in the middle. Okay, so there are two terminals of the battery. Okay, you already know all of this stuff. There's going to be a big terminal and there's going to be a small terminal. The bigger terminal is the one. Acha, beach mein na, there's obviously. Acha, so there's a big terminal. There's a small terminal. This is the positive side, and of the battery, that's your negative side. So remember, the electrons are already flowing. The electrons are already flowing. This side, electrons are being thrown out of the battery, negative side, and the other side, the electrons are coming in, right? So, so the electrons are coming in, and the current is already flowing, whether there's a reaction or there's no reaction. The electrons are already trying to move in this particular. They're already trying to move in this particular direction. So the electrical energy is already there. Okay, so remember, it's the opposite of. It's exactly the opposite of a cell. Now, because of this, what happens is that your solution is going to have a bunch of ions. So since it's NaCl aqueous, that means okay, there's going to be Na plus ions. This side is your negative cathode, and that side over here is my positive anode, right? So one side is anode, the other side is cathode. Achha, so what happens is that Na plus one is going to get attracted to the cathode because it's negatively charged. And Cl minus one is going to get attracted to it's going to get attracted to my anode because it's positively charged. So cathode attracts negative ions, attracts positive ions. And your anode, it attracts your negative ions or anions, okay? Acha, what else is present? Electrolysis of NaCl aqueous. What else is present in the solution? क्या होगा? Anyone, any idea? Saina, Jodi, Minahil, what else is present in?
Hydrogen ions
ठीक है. अच्छा, so
because it's
remember,
aqueous.
हाँ, ठीक है. So it's aqueous, right? So in O levels you studied that if it's aqueous, right? So what does that mean? It means that there is water, right? And when there is water, there is H plus one and there is OH ions. Achha, but now what you're going to study is that yes, there is H plus one and there is OH ions, but the quantity of H plus one and OH ions is negligible. It's almost. I mean, they're almost not there. The concentration of H plus one in a normal standard condition is 1 times 10 power minus 7 mole per dm cube, which is like almost close to zero. So there is actually very little H plus one and OH ions. Okay, so in O levels you did this, but over here you're not going to do this. The amount of H plus one and OH ions, that's negligible. So these are almost non-existent. Is that clear? So water,
Yes, sir.
it does ionize, but it ionizes so little that these ions will hardly play any role. I mean, you won't even, I mean, if they come and I mean, there's so little that you would hardly ever find them, right? So there is no H plus one in OH ions. Okay, that's the first thing. They're almost non-existent. So what is there? There is water basically. And remember, water is neutral. So if water is neutral, so water is going to be everywhere. So there's going to be water at cathode and there's going to be water at anode as well. Is that clear? Zaina, Jodi,
Yes, sir.
Zohair, is this clear?
Yes, sir.
Okay, so there's water, right? So keep that in mind. Don't ionize water because there's going to be H plus one if there's an acid. There's going to be OH ions if there's a base. But if it's just aqueous, barely any H plus 1 or OH ions. So what happens at cathode? Cathode reduction happens at cathode. Substances, they're going to try and gain electrons because the battery is throwing electrons towards them, right? So they don't have a choice. The only thing that they're going to do is they're going to try and gain those electrons, right? So remember, in the previous case, in a cell, you had a choice. Like the higher potential gains electrons, the lower potential loses electrons. But now you don't have a choice. The only option you're left with is gain of electrons. That's it. And who gains electrons? The one, or who has the higher tendency to gain electrons? The one that's got the higher E naught, right? Is that clear? So at your cathode, that's the only thing that's going to happen. So all you have to decide is who's going to gain electrons. Is it going to be Na plus 1 or is it going to be H2O? Who gains electrons? Now, you're going to open the data booklet and you're going to look for equations or electrode reactions where Na plus 1 and H2, because remember, the only option you're left with is at cathode. I mean, they can't lose electrons. The only option you have is they're going to gain electrons. So you're going to open the data booklet and you're going to try and figure out equations where Na plus 1 and H2O are gaining electrons. So if I look over here, so you're going to look at the equation in the forward direction. So Na plus 1 is over here in the forward direction. It is gaining electrons. So I'm going to copy this. Okay, and I'm only looking at the reaction in the forward direction. That's it. Okay, we're not looking at the reaction in the just the forward direction. That's the only option you're left. I mean, there's no reverse. There's nothing backward is not going to happen. So that's the only thing that's left. So we're going to try and figure out who gains electrons. Water. I'm going to try and figure out equations where water is gaining electrons. So if I look over here somewhere, there's one equation, this. And remember, I only have water, so I just need water gaining electrons. So that's the only one that's where I see water with plus electrons. That means water gains electrons. And remember, no reverse option. Only thing is, the only option you're left with is that they're going to gain electrons. That's it. Is that clear? And and between these two, who's got the high E naught? It's water that gains electrons. Is this clear?
Yes, sir.
So water is the one that's going to gain electrons. And so this is the reaction that I'm going to go with because it's the high E naught, and therefore that's the one that's going to gain electrons. TNH2 gas is going to get formed. So that's it. That's how you figure out what's going to happen at cathode. Is that clear?
Yes,
And
sir.
and at anode, I'm going to do the opposite, which is at anode, the battery is going to try and take away electrons. So it's going to pull electrons away from the whatever substance you got. So they're going to try and lose electrons. And so who's going to lose electrons? Is it going to be Cl minus? So the oxidation happens at anode, which means that they're going to try and lose electrons to the battery. And who loses electrons? The one that's got the lower E naught. That's got a higher tendency to lose electrons. So I've got two options. I've got Cl minus 1 and I've got H2O. So remember, I'm going to look for equations where they are losing electrons. So reverse direction. So there's this equation. You can look at it in the reverse direction where they are. So this equation is, and remember, losing electrons. So that means I'm looking at this equation in the backward direction. Is that clear? Cl minus 1 losing electrons. And I've got water as well. So I'm going to try and figure out water losing electrons. So I'm going to look for the equation in the reverse direction. So I've found two equations where water is losing electrons. One of them is, so one of them is this one. So water losing electrons. And remember, look at the equation in the backward direction. Okay, so it's water losing electrons. And there's another one which is, there are two equations. That was the first one. There's another one where water is losing electrons, and that's one. That's this one. So in the reverse direction, it is losing electrons. So who wants to lose electrons? The one that's got the lowest E naught. And in this case, the lowest E naught is 1.23. So that means this has the highest tendency to actually, it's got the highest tendency to actually lose electrons. So we figured out who gains electrons and who loses electrons. Is this all clear? Okay, when you talk about electrolysis, there was Na plus one, there was Cl minus one, and there was water. Water did not ionize a lot, so I ignored H plus one and OH ions. Over here, I just had to figure out who gains electrons. So it was either going to be Na plus one or H2O. So I found equations of Na plus one and H2O gaining electrons. And I found that this is the highest E naught. So this one has the greater tendency to actually gain electrons. And the other one is who's going to lose electrons? The one that's got the lower E naught, that's the one that's going to lose electrons. And we found out that it was going to be oxygen. It's going to be water. That's the one that's going to lose electrons because that's the lowest E naught. Is this clear?
Yes, sir.
So this is electrolysis of vinyl clear है? Jodi, is this clear?
Yes, sir.
Okay, so the other thing is that we have we'll do more electrolysis. TK, we can do copper sulfate, aqueous, right? So when it's so electrolysis of copper sulfate quickly. So now I'm not going to waste a lot of time copying the equations. So let's try and do this as quickly as possible. We've got so I'm just going to copy the diagram. Now, when you have copper sulfate aqueous, the only difference that you're going to have is this is obviously negative and positive. I'm going to rub off the ions. So you've got copper 2 plus and you've got water, right? And on the other side, you've got sulfate and you've got water as well on that side as well. And you're going to look for who gains electrons at the cathode. Okay, so at cathode, you want to find out copper 2 plus or is it H2O? Who gains electrons? That's it. So go to the data booklet and try and quickly find out copper 2 plus gaining electrons, water gaining electrons. So I've got copper 2 plus over here. I'm going to highlight all of them. So I've got copper 2 plus gaining electrons. There's another copper 2 plus gaining electrons. And I see water gaining electrons over here. So there's an equation for, water gaining electrons over here. So three possible reactions. This could gain electrons, this could gain electrons, or water over here could gain electrons. Look at the voltages. The highest one is the one that's going to be have the highest tendency to actually gain electrons. So you've got 0.34, you've got 0.15, and this one is, I mean, you've got three options, right? So which one is the highest E naught? It's this one. This one has the greatest tendency to gain electrons. So I'm going to go with copper 2 plus gaining 2 electrons to form copper because that's got the highest E naught. Is that clear? ठीक है. Is this clear? Zaina, is this clear? Minahil?
Sir.
And this was what, 0.34 volts, right? That's it. And you're going to look at anode, right? At anode, what's going to happen is who's going to lose electrons? So is it SO4 2 minus that loses electrons, or is it H2O that loses electrons? So the question is, who loses electrons? So you're going to look at SO4 2 minus and H2O. So and you're going to look at the equation in the reverse direction. So there's H2O losing electrons. There's another H2O losing electrons. Let's see SO4 2 minus losing electrons. That's this one. There's SO4 2 minus that's also losing electrons, right? So we've got all three possibilities. Water losing electrons, SO4 2 minus losing electrons. You have these potentials 1.77. This is what 1.23, and this one is 2.01 moles. So who loses electrons? The one that's got the one that has the lowest E naught. That's got the greatest tendency to actually lose electrons. So the one that's got the lowest E naught, and that's this one. So I'm going to write this equation in the reverse direction. It's water turning into oxygen and 4H plus 1. So this one is water turning into oxygen and 4H plus 1 plus 4 electrons. And the E naught for this was, I think, 1.23 volts. Is that clear?
Yes, sir.
So you got these two different. So you can do this for a number of electrolysis. And you just have to figure out who gains electrons and who loses electrons. I say, one thing that they're going to talk about over here is I'm going to just put this on the side. Specifically about this reaction, the NaCl aqueous electrolysis. You had Cl minus 1 and you had water, they were losing electrons, right? Cl minus 1, water losing electrons, the lowest one loses electrons. Now, what happens is that you already know from O levels that if NaCl is concentrated, then it's always Cl ions that lose electrons. Is that clear? I mean, you know this from O levels that chlorine gas is produced when NaCl is concentrated, and they're going to ask you why that is the case. So the answer to that is they're going to ask you why that is the case. So the answer to that is that if Cl is concentrated, your electrode value, this electrode value, I mean, normally it's 1.36 volts, right? So if Cl is concentrated, the equilibrium would shift to the left. Like if you make it too concentrated, according to Le-Chatelier principle, the equilibrium will try to make it less concentrated and the equilibrium shifts to the left and produces more electrons. So your electrode value, it decreases. There's more electrons getting produced. The equilibrium is shifting to the left. So the equilibrium shifts to the left and more electrons get produced. And since more electrons are getting produced, that means the potential decreases. So the electrode potential, it decreases. And when it decreases, so let's say it becomes 1.15 volts, then look at the values. Then this is going to be the lowest potential. If it's not 1.36, if it's 1.15, then its electrode potential decreases. And Cl minus 1, Cl2, Cl minus 1 electrode becomes the lowest potential out of the three. And hence, chlorine is the one that's going to be preferentially discharged. So remember this, that they're going to ask you about this. I mean, the previous thing is pretty easy that you look at the species that you have in your solution. Higher gains electrons at cathode, and the lower one over here on the other side, it loses electrons. Uh, but if NaCl is concentrated, then it's always Cl that's getting discharged. Why is it getting discharged? Because your electrode, your 1.36 volt electrode over here, the Cl electrode, that becomes the lowest potential. Why? Because its equilibrium would shift to the backward side because it's more concentrated. And if it shifts backwards, the potential decreases. More electrons get produced, and your electrode value, your voltage on the electrode, it becomes more negative and it decreases. Okay, is this part clear?
Yes, sir.
So keep this in mind. As a simile, we can do I mean, that's pretty much it. You can apply the same concept to other electrolysis, which we are going to do while doing other past papers. Now, the next thing is that you have another small thing which is left is that there's a thing called Faraday constant. So after this, we'll start doing past papers in the next class. So Faraday constant is it's known as F. There's a formula which is F is equal to LE, and it has a value of 96,500 coulombs. That's the charge. It's Faraday constant is the charge. L is the Avogadro's constant. That's 6.02 times 10 to the power 23. And E is the charge on the electron. That's 1.6 times 10 to the power minus 19 coulombs. So in simple words, what is Faraday constant? Faraday constant is the charge on 1 mole of electrons. So 1 mole of electrons is this many electrons. It's 6.02 times 10 power 23. And the charge on 1 electron is 1.6 times 10 power minus 19 coulombs. So 1 electron has this charge. So 1 mole of electrons, you multiply it by 1 mole, you get 96,500 coulombs. Is this part clear?
Yes, sir.
So all you need to know is that if you have 1 mole of electrons, it's going to have a charge of 96,500 coulombs. That's it. And then there's another thing which you need to learn to solve questions, and that's which you already know if you're doing physics. It's Q is equal to current into time. That's another way of finding charge. It's Q is equal to IT. The current is going to be in amperes, and the time is going to be in seconds. So I'm just going to do a simple question, which is that, for example, find the mass of copper produced when what happens when CuSO4 is electrolyzed for, let's say, 1.5 hours with a zero point 0.2 ampere current. So let's find out, and let's say they gave us the equation of copper getting produced. It's this one, copper plus two electrons, and it's forming copper. Copper is getting deposited. So based on the information that's given, you can figure out the charge, right? Q is equal to IT, right? The current is given, that's 1.5 hours. That should be in seconds. So that's into 3600. 1 hour has 3600 seconds. Into the current, which is zero point 0.2. So that was time, 1.5 times 3600 seconds. And the current is zero point 0.2 amperes. So can somebody tell me what the value is? Anyone on your calculator, what's the value for this? What is the charge? Zaira?
864 sir.
864. So you're getting 860.
ये सर एक सेकंड नहीं ये 1080
So you're getting 1080
I
coulombs,
got
right?
1080.
Okay. Now, what do you do with the Faraday constant? What you do with the Faraday constant is it's going to be used to convert into moles of electrons. Like if you have charge, I mean, this is what you. So you know the charge. You know that 1 mole of electrons has what charge? It's got a charge of 96,500 coulombs, right? So if there's 1080 coulomb of charge, so how many moles of electrons you got? So you're going to cross multiply, and X will come out to be what? It's going to be 1080 divided by 96. So how many moles of electrons you got?
0.01
Need three significant 0.01 what?
0.011.
What's the third one?
It is 1 and then 9 है तो फिर 0.0112.
चलिए 112. नहीं 119 था?
Yes sir, it was 0.01119 तो वो फिर
अच्छा ठीक
2
है
हो
ठीक है
जाएगा.
ठीक है. अच्छा, so you found the moles of electrons, right? So once you have the moles of electrons, you can find the moles of copper, right? That's the amount of electrons that is. So it's what, 0.0112 moles? So if you know the number of electrons, the number of copper would be half of that, right? What is half of that? That's going to be, okay, a point zero. What do you get? 0.0056. यही आ रहा है.
Yes sir.
And then you have to find the mass. So what is the mass of copper? That's mass क्या होती है? That's moles multiplied by mr. So multiplied by the mr, right? So the mr is what? 63.5. So what is the mass that we are getting? The AR is
0.336.
0.336 grams. ठीक है
36 0.36 or 355.
ठीक है 36 grams. So ठीक है that's a typical question that you're going to get on Faraday constant. ठीक है So all you need to know is Q is equal to IT and you need to know the charge on one mole of electrons. ठीक है So next class we'll do past papers. We'll just do past papers of this. ठीक है we're pretty much. I'll just check if we have missed anything, but that's pretty much it. ठीक है electrochemistry. So we'll just do past paper questions from the next class. ठीक है So let's continue next time then. Okay, everyone.
Office.
Office.